In this lesson, we convert numbers from other bases into base 10. We do this by expanding the number according to its place values, where each place value is a power of the base. Every digit in a number has a position, and each position has a value. Starting from the right-hand side, the positions are counted as 0, 1, 2, 3, and so on. So the rightmost digit is multiplied by b to the power of 0, the next digit is multiplied by b to the power of 1, the next by b to the power of 2, and we continue in that way. For a number written as an minus 1, all the way to a1, a0, where these a's are the digits of the number from left to right, in base b we expand it as an multiplied by b to the power of n plus an minus 1 multiplied by b to the power of n minus 1, all the way to a1 multiplied by b to the power of 1 and a0 multiplied by b to the power of 0. The calculation is then done using normal base 10 arithmetic. Let's look at an example of a base 7 number, 15. The number is 15, but the base is in base 7. So the place values are the powers of 7. The digit 1 is in the 7 to the power of 1 position, and the digit 5 is in the 7 to the power of 0 position. So we get 1 multiplied by 7 to the power of 1 plus 5 multiplied by 7 to the power of 0. Since 7 to the power of 1 is equal to 7 and 7 to the power of 0 is equal to 1, this becomes 1 multiplied by 7 plus 5 multiplied by 1. So we have 7 plus 5, therefore 15 in base 7 is the same as 12 in base 10. So the symbol 15 in base 7 represents the value 12 in base 10. Let's look at another example of a binary number, 111010111 in base 2. Since this is in base 2, the place values are powers of 2. Working from right to left, the powers are 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, the power of 3, and so on. So we can expand the number as 1 multiplied by 2 to the power of 7, plus 1 multiplied by 2 to the power of 6, plus 1 multiplied by 2 to the power of 5, plus 0 multiplied by 2 to the power of 4, plus 1 multiplied by 2 to the power of 3, plus 0 multiplied by 2 to the power of 2, plus 1 multiplied by 2 to the power of 1, plus 1 multiplied by 2 to the power of 0. If we evaluate each term, we get 128 plus 64 plus 32 plus 0 plus 8 plus 0 plus 2 plus 1. Adding these together gives you 235. Therefore, the binary number 1110111 is 235 in base 10. The reason why this works is that every positional number system follows the same pattern. For example, in base 10, the number 234 means it comprises of 2 hundreds plus 3 tens plus 4 ones. That is the same thing as 2 multiplied by 10 to the power of 2 plus 3 multiplied by 10 to the power of 1 plus 4 multiplied by 10 to the power of 0. Other bases work in exactly the same way. In base 2, the place values are powers of 2. In base 7, they are powers of 7. In base 16, they are powers of 16. The conversion method expands the number by interpreting each digit as a contribution towards the total number of base 10 ones. Although the original number is written in another base, where the intended place value structure comes from multiplication and addition in that base, the conversion rewrites those place values as base 10 quantities. The powers of the base tells us how large each place is, and the digits tell us how many of those places we have. Once all those contributions are counted as base 10 ones and added together, we have the base 10 value of the original number.